Hello viewers, I hope you are all fit and fine. Today we'll be describing this scheduling basic. So in this scheduling basic we will learn number 1 about the activity. We'll learn about the estimation of activity duration, estimation of activity duration, and we will learn about relation between activities. These are the very one of the most important concept. This will be required for any planning stage. So here we'll be elaborating about the basic of the scheduling. Now, what is activity? What is activity? The activity may be defined as an element of construction project subdivided into various manageable steps. This is the definition of an activity in simple. An activity always have a recognizable start and end. So now the types of activity. Types of activities. Types of activities are value added, number 1, that is value added activities. Value added activities means any activities, that is construction phase activity, design phase activity, the activity is directly related with the execution, that is value added activities. There are also non-value added activities. Non-value added activities. These non-value added activities means the break in the working schedule. Break in the working schedule. In the working schedule. This is non-value added activities. There is also another thing, that is non-value added necessity activity. This is necessity activity. Non-value added necessity activity. So this is activity for audit, safety audit, augmentation and also admin activity. So these are the types of activities. Now we will refer to the estimation of activity duration. So this estimation of activity duration, this is the most difficult time management to execute the exact duration of a particular activity. Now this activity with low estimate duration and activity with high estimate duration are always very challenging. Now this duration of activity is done on the basis of some assumptions. So what are the 4 assumptions that is to be keep in mind while going for the estimation of activity duration? Number 1 is perform activity as per normal. This is the number 1 assumption. And number 2 is estimation to be done on the basis of uniform production rate. Number 3, this is to evaluate each activity as per on the basis of construction. Number 4, evaluation, or rather I will say estimation to be done on day basis instead of hourly basis. So these are the 4 assumptions to be followed while going for the estimation of activity duration. Go to the techniques of estimation. What are the various techniques of estimation? Number 1 is expert judgment. This is the technique most widely used nowadays, and in this technique actually they used to take the data from similar type of project, and the same duration is applied for the project they are going to be planned. So this is the relies on his expertise and mainly the expertise person are entrusted with this process. And number 2 is analogous estimating. Analogous estimating. This is done with the reference with the analysis of estimate of similar type of project. This is analogous estimating. And number 3 is heuristic estimation, that is heuristic estimation. This is mainly a thumb rule type estimation. These are mainly the mathematical concepts are used in this heuristic estimation, and there is no expertise about this estimation, and mainly the people entrusted with this heuristic estimation are not the expertise in this field. And number 4 is parametric estimation. This parametric estimation. Actually, parametric estimation means suppose you are going for the construction of a slab or a beam, and for that execution of a slab or the beam, what are the parameters involved there? Mainly the thickness of the slab, the cover to the reinforcement, the dia of reinforcement, the spacing of reinforcement, the designing aspects, everything these are used to be considered in this parametric estimation. And the another important is the Delphi method, which is the Delphi techniques, you can say. This Delphi techniques is mainly the brainstorming with various expertise, and they used to go for the micro detailing of this project, and they used to go for a trial and error. Ultimately, finally, they arrived for a specific date of that estimation. But one of the drawbacks of this Delphi estimation is the time required for this estimation is very longer, because as there is a accumulation of many number of expertise, and there is a huge brainstorming, and these are mainly used for big projects, very huge projects that require a perfect estimation. For these Delphi techniques are used. And the other is phased estimating. Phase estimating. And number 7 is top bottom estimation. Top bottom estimation. Number 8 is bottom top estimation. And finally, the number 9 is Monte Carlo simulation. So these are the various techniques of estimation. Now let us see how to find out the direct method using total quantity and daily production rate. Suppose we are to go for a painting of 400 square meter area. We are to go for a painting of 400 meter square area with a group of worker who can cover 12 meters square per day. So what will be the total number of days required to complete this work? Therefore, the total number of days required to complete this painting work will be 400 divided by 12, that is equal to 33.33 days, so equal to 34 days. So in this way we can find out if the area is known and the per day coverage is known, then we can find out the number of days. Now the question appears, where from we will get this 400 meters square, and where from also we will come to know about this 12 meters square per day. For this 400 meters square we will have the RFC drawings. In the RFC drawings we have to estimate the area required for the execution. That we can go for long wall, short wall method, we can go for central line method, and the same way we will find out the exact area required for execution. And regarding this coverage or the consumption per day, there is a big question. This is the question always hovering in the mind of everybody. In fact, in many of my webinars I have faced many questions from the aspirants. How will get this 12 meters square per day, or what this consumption rate of this labor per day, from where we will get? Actually, for this we can refer one IS code, that is IS 7272 1974 for the beginners. This IS code is very much helpful, because from this IS code they can take the basic idea of the various components that is used in the construction. But there is a limitation in 2020. You cannot exactly refer to that IS 1974 72 72 of 1974. So you have to also adapt the experience of how the production rate of these workers are performing nowadays. And for making the habit of that, it is a best practice to maintain a diary and to note the activities, whatever activities that is going on by the side of you, or any activities that you are interested with. Please note each and every activity, how the workers are giving, how much output you are getting from the workers, and that experience will actually come handy in this case. So this is the main concept of direct method of using total quantity and daily production rate. Look at this. There is an earth moving operation. I have drawn one excavator, and this is a loader, this is a dumper, and this is also a dumper. So this activity, this is excavation is going on here. This is excavation. The loading is going here. This is loading, and this is hauling. Hauling, that is, this is hauling. This is the transportation of this excavated earth through these trucks. Now, so let us specify that the performance of excavator is 200 m³ per day. Performance of loader is 250 m³ per day. Performance of 3 number trucks are 150 m³ per day. Now the question is, from where we used to get this performance of excavator is 200 m³ per day, and this loader is 250 m³ per day, and these 3 trucks are 150 m³ per day. That can be available from the manufacturer specification. The excavator that you were using or the loader that you were using, the manufacturer will provide you the capacity of execution per day. So now let us find, suppose we are to excavate 5,000 m³ earth. So the criteria of daily performance is given here. From here we are to find out, so how much day this activity will move. So the excavation will continue for 5,000 divided by 200, that is 25 days. 25 days. That is, excavator will require 25 days. And this loading 5,000 divided by 250. It is 5,000 by 250. Now this loading will take 5,000 divided by 250, that is 20 days, and this hauling will take 5,000 divided by 150, that is, it will come there about 34 days. So here the entire activity will take 34 days, and out of this entire activity, excavator will work for 25 days, loader will work for 20 days. That means this excavator is idle for 9 days, and this loader will get idle for 14 days. So there is underutilization of resources in this program. So now we have to rethink how this underutilization can be minimized. For this reason, if we can increase 3 trucks to 4 trucks, then if we increase these 3 trucks to 4 trucks, then their consumption will be 200 m³ per day, because the 3 trucks consumption was 150 m³ per day, means per truck the consumption is 50 m³ per day. So if we increase one more truck, So consumption for 4 trucks will be 200 MQ per day. So here the truck consumption will now, this is 5000 divided by 200. So now the hauling operation will take 5000 by 200, that is 25 days. So here what we will see, this total activity has get changed to 25 days, and this excavator we are using for 25 days, so there is no idling of excavator. Only this loader will get idle for 5 days instead of 14 days. So this loader will get idle for only 5 days instead of this 14 days. That is the minimum underutilization. This is the way we have to work it out, and we can do the planning in this way. So I hope this my aspirants, my viewers are able to understand what is the focus of this seedling basic. So if you were moved by the video, please like it, share it, please write comments in the comment box. Your inspiration will help me to explore more. This is Debabrata Chakraborty signing out till we meet again.